Hi, I'm Assam, the lecturer here at the Institute of Medical Education, and today we're going to take a look at solutions to Section 3 of ACER's GAMSAT Pink Booklet, Practice Test 3, specifically Unit 33, questions 90 to 93. And in this unit, we're going to take a look at DNA and some of the rules you need to kind of know. Hopefully, you would have known these rules before you sat this exam, but now you should know the rules. But these rules are important in order to work with DNA and answer questions that could come up in the GAMSAT, which have come up in this exam. So the following rules, well, they're not explicitly stated in the unit stimulus, but if you do read the unit stimulus properly, you should generate about 3 or 4 rules. So they are as follows. The first couple, so adenine and thymine, they form 2 hydrogen bonds between strands. So we can see that in the figure in the stimulus, the figure in the stimulus. Guanine and cytosine, they form 3 hydrogen bonds between strands. We can also see that. Hydrogen bonds isn't that important for this question, but it could be important in future GAMSAT questions, so keep that in mind. We're told that strands are arranged from 5' to 3', and they can bind in the direction of 5' to 3' to 3' to 5'. So when we say that, if you take a look at the double-stranded DNA in the unit stimulus, we see that we've got our 5', so it's going in this direction to 3', can't even write here, so 5' to 3', and then we've got our here, so it's going to be our 5' to 3', and you can see our base pairs here. So that's the direction, and that's what it's telling us. And finally, the rotation of strands can reveal identical sequences. So what we mean by that is 5' GC 3' is exactly the same as 3' CG 5'. So it's exactly the same sequence. So that's important to note because it's there's a couple of questions relating to this rule. Now, finally, they do present us a table with DNA sequences and possible strands for these sequences. We'll get to this for question 92. But just focus your eyes on A and T base pairs in the table because that's the question. That's what the question is asking us. But we'll get to that in a couple of questions. So first, let's just focus on question 90. So question 90 says, consider the single-stranded sequence 5' G A T A T C 3'. Which of the following sequences would base pair with it? This is going back to high school biology. Base pairs, remember the 2 rules up here. So adenine binds with thymine and guanine binds with cytosine. So let's just write it. And we know that it has to bind. So 5' to 3' binds with a 3' to 5'. So it's going to go 3' to 5'. So it's going to go G, C, A, T, A, T, A, G. So now we just have to look through the options available. Which one has 3', C, T, A, T, A, G, then 5'? So the only option there that satisfies this is option A. So everything else is incorrect. And just double check. So you can look at option A. So it's got 3', C, T, A, T, A, G, 5'. So remember what we said here. Rotation of the strands can reveal identical sequences. So they've kind of tricked you here. So you're used to seeing, oh, but it has to go from left to right. But it can actually go from right to left if you conserve, obviously, the sequences here. So the directionality. So that's the key. So the answer for 90 is A. So now if we take a look at 91, it says which of the following represents identical double-stranded sequences. So it's the same principle here. So you can kind of eyeball this straight away. And you know that if you're going to have it, say for example, A, it's got CAGT, the opposite strands have to have a CA and a GT. But you can see that in the opposite strand for A, you've got CT. It's not possible. It has to be either AC or TG. So the answer for A is incorrect just by eyeballing it. B, same principle. It has to be incorrect because you have to have a CT in the opposite strand. That's incorrect. So we know it's either between C or D. So we can kind of write it out anyway. So let's just write it out. So you've got 5' AT, 3', then you've got a 3' TA, 5'. If we're going to use this rule, we know that it has to be, so 3' TA, 5', 5' AT, 3'. That's what it should look like. And do we see that for C? We've got a 3' TA. Nope, they have a 5' TA, a 5' AT. So yep, C is incorrect. So therefore D has to be correct. And the reason why D is correct is that you can see that if you do 5' AG 3', 3' TC 5', without even looking at the options, you know it's going to be 3', so G, so yep, GA 5', that's going to be 5' CT 3'. So if we take a look at the options, so 5' CT 3', 3' GA 5', yep, so that's why D is our answer. Again, you just had to use this rule over here. So now getting on to 92. 92 says, how many different double-stranded sequences containing only A and T are given in the table? So in the GAMSAT, what you do is you just look at the table and just focus your eyes solely on this part of the table. I know now that the GAMSAT is online, you can't just circle it in the exam. You can't just draw on your computer. You might have to draw this in your I think they give you a couple of scrap pieces of paper ACER gives you to draw this on. But just focus your attention on it and you can see it's asking how many are different. How many different double-stranded sequences can you find? So let's take a look. So this sequence, straight away you know is going to be exactly the same as this sequence, because 5' AA 3' is the same as 3' AA 5'. So you can see that. Same thing here, 3' TT 5' is the same as 3' TT 5'. So these sequences are the same. So let's just count that as one sequence. So let's see if these sequences are different. So how about we just write it down? 5' TA 3', 3' AT 5'. So the sequence that's going to be identical would be, so the identical should be, so if we take a look, 3' AT 5', this side should be 5' TA 3'. So are they the same? So let's have a look. So we did this side. Is this the same as this? So we've got 3' AT 5', so that's 5' AT 3', and 5' TA 3'. So no. So this double-stranded sequence is different to this double-stranded sequence. Therefore, we have, if we take a look at the options for 92, 3 different double-stranded sequences. So that's why the answer for 92 is C. This one just required you to use this rule, but I guess the trick was just knowing that this sequence and this sequence were exactly the same. So now on to 93. So the last question, this is a nice one. A lot of information there, but all you need to know is we have a 16 residue single-stranded DNA, which was chemically synthesized, and we give you some rules. It says assume that any double-stranded DNA molecule conforms to the adenine, thymine, and guanine, cytosine base pairing rules. It also says that base pairing can occur between a single strand, and it can occur within a single stranded molecule. So the question is asking, in a solution containing strands of only this DNA. So we've got a solution that only contains this. So let's see if I can draw this. So GT A T, so GT A T A C C G G T T A T A C. So that was, at least we know I can count. So that's 16, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, so I can, not only can I count, but I can also write sequences just by looking at them on the paper. What a superpower. So we're told that we have just this sequence in a solution and other sequences are floating around. And we're asked, what is the longest double-stranded molecule that this sequence can form? We're told that this sequence can obviously form base pairing with other DNA sequences. And we know straight away when we look at the options, it says either 0, 8, 16, or 32 base pairs. We know the answer can't be 32 base pairs because you've only got 16 bases. And you know that if you have 16 bases, you can only form 16 base pairs, which means you can only form, well, that's it. You can't extend or elongate this sequence, right? So you can only have 16 base pairs formed. So you know, therefore, D is incorrect. So we know it has to be between 0, 8, and 16. So what you would do is, remember, take a note of the rules. Rotation of strands reveals identical sequence. So if we take a look at 3' to 5', how about we write these backwards and see what it is? So 3', so to 5', so we're just going to go backwards. So C, A, T, A, T, T, G, G, C, C, A, T, A, T, G. So this strand is exactly the same as this strand because we just wrote it backwards, and we know that's true because of the rule here. Rotation of strands reveals identical sequences. Now, if we want to see if there's 16 base pairs, let's find out if this molecule can bind to itself. So remember, adenine, thymine can bind, and guanine, cytosine can bind. So let's see. So GC, yep. TA, yep. AT, TA, AT, AT, CG, CG, GC, GC, TA, TA, AT, TA, AT, CG. Fantastic. So if we actually just turn the molecule around, we can see that one strand of DNA can actually form 16 base pairs with itself, which is fantastic. I mean, ACER did this on purpose because they wanted to see if you were quick enough in the exam to know that you can flip this around. I mean, if you can utilize the rules they presented and try to see if they base pair. So that's why the answer for C, it says the longest double strand molecule that can form is 16. So the answer for 93 is C. Now, this unit required you to utilize a couple of rules. I mean, you should have known these rules hopefully before sitting the exam, but you do know these rules now. But in future GAMSAT exams and the questions ACER might pose, it might have something to do also with hydrogen bonding between the base pairs. Don't forget that. And the properties, or let's say acidity, basicity, and the different kinds of properties of these, let's say, bases. I mean, you could also include amino acids if you want in the list, and there's a lot that you can also talk about when it comes to DNA. But in this instance, you just have to utilize the rules. But if you're still having difficulty with this unit and you want more, I guess, further clarification, you can post your comments in the comment section below, or you can contact us directly. We'd love to help. Thanks for your time. Bye now.